To understand how the sympathetic nervous system, so epinephrine and norepinephrine, can influence the cardiac output, we have to understand the excitation contraction coupling in cardiac muscle cells. So this is a cardiac muscle cell, and it has some similarities but also some striking differences compared to skeletal muscle. So we can start labeling this. We can see we have the sarcolemma here, or the plasma membrane. And we also have T-tubules just like we have in skeletal muscle. And we have our actin, which is our thin filaments, and our myosin, our thick filaments with their heads. So these are our myofibrils. And so one of the things that you'll notice that's prominently missing is a motor neuron. So there's no neural connection between any neuron and the surface of this cardiac muscle fiber. And so where does the action potential come from? It comes from gap junctions. So it comes from gap junctions either from another autorhythmic cell or another pumping cell. So AP from gap junctions. And so it goes zooming across the fiber down the T-tubules where it causes a voltage-gated calcium channel to open. And then calcium, which is more abundant outside the cell in the interstitial fluid, and remember, T-tubules are filled with interstitial fluid, calcium enters the cell, and it opens a kind of channel you guys have never heard of before right here. This is a calcium gated calcium channel. So calcium binds with that as a ligand, and of course this is calcium stored in the SR, and causes it to open, and more calcium comes out, and that joins from calcium. It came from these voltage gated channels and out of other channels on the sarcoplasmic reticulum. And we then have calcium binds with troponin, and the actin-myosin cross-bridge cycle gets started just like it does in skeletal muscle. So we have calcium troponin pulling tropomyosin off the myosin binding sites of actin, and the whole cross-bridge cycle happens. We have, for the muscle to relax, similar to skeletal muscle, we have a calcium ATPase that puts calcium back. We also have calcium can be pumped out of the cell as well in exchange for sodium. So we have calcium ATPase pumping calcium back into the sarcoplasmic reticulum to cause relaxation. So I'll put relaxation. Oops. And calcium being let out is what causes contraction. So when we have sympathetic stimulation, epinephrine and norepinephrine have a couple of different effects. They have effects on calcium entry into the cell. So sympathetic stimulation leads to increased permeability to calcium. So that means more calcium enters and more calcium binds with troponin. So here's another difference between cardiac muscle and skeletal muscle. Cardiac muscle has a graded response to calcium. So cardiac muscle has graded response to calcium. So that's kind of like smooth muscle. So the more calcium that binds with troponin, the stronger the force of contraction. If you have less calcium entering, you have less contraction. And this kind of makes sense because cardiac muscle is not organized into motor units, and the whole heart has to contract in a organized way in order to squeeze blood from the atria to the ventricles, and then the ventricles back up to the aorta and pulmonary artery. So you can't just have part of the heart contracting, so the whole thing has to either contract hard or not so hard. So one effect of sympathetic stimulation is for increased permeability to calcium to cause a stronger force of contraction or greater saturation of troponin with calcium. The other effect here is here on this protein. So this is number 2, and we upregulate the calcium pumping. So calcium pumped out of the cytosol faster. So this gives the heart more time to be relaxed and fill with blood. If you relax more quickly, then you have much more filling time, and the more blood that fills the heart, the greater the stroke volume. And this is actually Starling's law. If we have more blood returning to the heart, we squeeze harder and we pump more of it out. And as the heart fills with blood and stretches, these channels right here respond to stretch. So I'll put also respond to stretch. And that means as you stretch these channels, because the heart's filling with more blood, then more calcium enters as well, and you end up with a stronger force of contraction. So under the effects of sympathetic stimulation, more calcium enters, we have more calcium troponin interactions, we have more actin and myosin sliding, and we have a stronger force of contraction. But at the same time, we're putting calcium away faster, so we have a quicker relaxation. So it contracts strongly, it relaxes quickly, and it has more time to fill with blood, and that filling with blood stretches it and causes even more calcium to enter. And so again, contributing to that stronger force of contraction and also increased stroke volume.